Hey guys, I'm Adam, and this is the second video of our SHSAT YouTube channel, and today's video is going to be math, fractions, and mixed numbers. So before we get into some practice problems, I just want to cover a few key points that I think you guys should know. And the first one is that fractions and decimals can be converted from one another. So a fraction can be converted into a decimal, and a decimal can be converted into a fraction. So here we have a few examples. The simplest example is 7 divided by 10, 7/10, that is equal to 0.7, right? And the reason that is because a fraction, intuitively, right? A fraction means something divided by something. So 7 divided by 10. And that means that we can do long division on it. So if we do 7 divided by 10, how many times does 10 go into 7? 0. So we have to bring down another 0 and a decimal point. How many times does 10 go into 70? 7, right? So 7 times 10, 70. Subtract, you get 0. So that's how we get 0.7, right? And here we have another more complicated example, 14 over 81. And the reason I put this here was to show to you that you don't have to have a really clean denominator like 10 or 100 or 1,000 in order to figure out how to convert. This always works. So in order to convert this to a decimal, you have to do 14 divided by 81, and that is equal to 0.172839 repeating, meaning that it goes on forever and ever and ever. There are some types of problems on the SHSAT that need you to think about those types of decimals, repeating decimals. We'll get to that at a later date. And now let's look at converting backwards from a decimal into a fraction. So let's take the decimal 0.398. In order to convert that back, you have to go back the number of zeros, right? So here we have to go back 3 zeros in order to completely make it, to move the decimal point behind the number, right? So now we do 398 over 1 and 3 zeros. And this is how we do that for every type of fraction, every type of decimal that we want to convert into a fraction. So let's take another decimal, 0.5642. We have to move the decimal point 1, 2, 3, 4 times. So we're going to have 4 zeros. And now, why is this important? Well, you can generally use fractions and decimals interchangeably. They do the same thing, right? I personally prefer fractions because I feel like it is easier to work with them in some cases, but there are going to be certain problems where it makes more sense to work with decimals or fractions, and it really depends on the question. But the reason I'm showing this to you is that if you prefer one way over the other, you can kind of change the problem to fit your needs. So on that note, let's go on to our next key point, which is that mixed fractions can be converted into improper ones. So what even is a mixed fraction? Well, let's take this example, 7 and 3/9. So the 7 is our whole number. It is the amount of full 9 out of 9, so we have, right? So 7 is how many 9 out of 9s we have. So to figure out how many 9 out of 9s we have in 7, we do 7 times 9, that's 63. So 63 over 9, right? 63 divided by 9 is 7. So that's how we know that we're right. And then this part is going to be our fraction. And here we have 3 out of 9. So that's the amount that we have left over after we do that whole conversion. So we have 3 out of 9 more. So we can just add 3/9, and that's how you get 66/9. And that is now in its improper form. Let's look at another example. So here we have 14 and 2/3. So the way we convert is we do 14 times 3, which is 42. And then you add the 2, and that makes it 44. And then all that is over the denominator of 3. So that's how we convert from a mixed to an improper form. And the reason why this is important, which you'll come to see in a few minutes, if you don't know already, is that it is generally much easier to work with improper fractions rather than mixed ones. When you want to add or subtract, and sometimes when you multiply and divide as well, it is so much easier to just use improper fractions and then convert back afterwards rather than trying to figure it out in a mixed form. So on that note, let's move on to our adding, subtracting, multiplying, and dividing with fractions. Here's our first case, adding two fractions. So in order to add two fractions, they need to have a common denominator, which means that the number on the bottom has to be the same for both. So here we have 4/3 and 2/9. So what can we do to this to make it have a 9 on the bottom, we can multiply by 3 over 3, which is equal to 1, right? So you can't actually change the fraction. You can't just make this equal to 9, right? You have to preserve the equality. So by multiplying by 3 over 3, we're not changing anything. We're just multiplying by 1, right? So by multiplying by 3 over 3, that turns into 12 over 9, right? Because 3 times 4 is 12, 3 times 3 is 9. So 12 over 9 plus 2 over 9, that equals 14 over 9. And that is in its improper form. And if you want to turn it into mixed form, right, how many times does 9 go into 14? 1. And then what do we have left over? 5/9. So that is the equivalent form in mixed form. Now, let's look at subtracting. So here we have 5/7 minus 3 2/3. This is in mixed form, so we have to convert this into improper form in order to subtract these. So that's what we're going to do first. We're just going to convert to improper form. So we have 5/7, and then 3 times 3 is 9, plus the 2 up here, that's 11, 11 over 3. So we have 5/7 minus 11 over 3. Now, we can convert these into having a common denominator. And so what we're going to do is and this works for every fraction, you can do the numerator of the first fraction times the denominator of the second one, minus or plus, depending on if you're adding or subtracting, the denominator of the first fraction times the numerator of the second fraction, right? So 5 times 3, is 15, and 7 times 11 is 77, but because we have this minus, it's going to be negative 77. And then the denominator is going to be 7 times 3, which is 21. So now we have a common denominator, and you can just simplify this. So when you subtract, you get negative 62 over 21, which is going to be your final answer. And you can also obviously convert to mixed, but I'm not going to do that right now. Our third type is multiplying. And multiplying is actually a lot easier than adding and subtracting because unlike in adding and subtracting, you don't need a common denominator here. But here we have two numbers in mixed form, so we are going to have to convert those into improper form. So like usual, 8 times 2 is 16. 16 plus 3 is 19. 19 over 2 are going to be the answer to our first one. And then the second one, 12 times 4, 48, plus 7 is going to be 55, and then it's going to be over 4. So 55 over 4. Now, we can just multiply them. So multiply the top by the top and the bottom by the bottom. So 2 times 4 is 8, and 19 times 55, you guys can calculate that on your own. I saved you guys the hassle. It's 1,045. And so that is going to be the answer to this question. Obviously, you can also convert back to mixed. And now our last type of operations we can do with fractions is going to be dividing. And here we have 9/2 divided by 27 over 8. And so what you do when you're dividing a fraction by another fraction is you flip the second fraction. And why does this work? Well, let's say you had 10 objects, right? And you wanted to split them into 2 equal groups. You could either divide that by 2, right? Because 10 divided by 2 gives you 5. You have 2 groups of 5. Or you could multiply that by 1/2. 10 times 1/2 is also 5, right? So that is how dividing with fractions work. You can flip the numbers. So 2 was flipped from 2 over 1 to 1 over 2. And that's what we do here. So 9/2 divided by 27 over 8 becomes 9/2 times 8 over 27. And now this is just like our multiplication problems where you just multiply the top and the bottom. So 9 times 8 is going to be 72, and 2 times 27 is going to be 54. Now, both of those are divisible by 9, right? 9 times 8 is going to be 72, and 6 times 9 is going to be 54. So we have 8 over 6. We can divide both by 9. And then here we can further simplify dividing by 2 to get 4 over 3, which is going to be our final answer. So now that we've looked at this, let's go look at some actual example problems from real previous SHSATs. So here's our first one. 100 times 2 plus 0.1 squared minus 100. So the first thing we're going to do here, because I personally prefer working with fractions, is I'm going to convert this to fractions. So we're going to have 100 times 2 plus 1/10 minus 100, right? Squared. And now you have to remember your order of operations here. You always have to do the stuff inside of the parentheses first. So let's just do that here. 2 plus 1/10 times 2 plus 1/10. 2 times 2 is going to be 4. 2 times 1/10 is going to be 1/5. Let's just make that neater, 1/5. And then we're going to have to do that again, plus 1/5. And then 1/10 times 1/10 is going to be 1/100. Now, simplifying this, we can get 4 plus 2/5 plus 1/100. Now, we can make a common denominator here, right? So let's convert these all to a common denominator of 100. So we can have 400 over 100, that's just 4. Plus, you will have to multiply this by 20 and this by 20. So plus 40 over 100 plus 1/100. That's going to be equal to 441 over 100. So that's the part inside of the parentheses. But now we see that we have to multiply by 100. So 441 over 100 times 100 is just 441. And now that we've done that, you have to just subtract 100. So 441 minus 100 is 341, which is answer choice D. Now we have our next question. Here we have 2 and 1/5 plus 3 and 3/10 plus 4 and 2/5 plus 5 and 1/2, and we just have to simplify this basically. So the first thing we're going to do, because we have mixed numbers here, is we're going to convert everything to improper form. So 2 and 1/5 is going to be 2 times 5 is 10, plus 1 is 11, so we're going to have 11/5, plus 3 times 10 is 30, 30 plus 3 is 33, so 33 over 10, plus 4 times 5 is 20, plus 2 is 22, so 22 over 5, plus 5 times 2 is 10, plus 1 is 11, so we have 11 over 2. Now we need to get these all to have a common denominator, so we can add them. And we see here that in order to get to 10, we can multiply these two by 2 over 2, this by 2 over 2, and this by 2 over 2. And we can multiply this by 5 over 5, right? So now let's do that. We're going to get 22 over 10 plus 33 over 10, because that one doesn't change, plus 44 over 10 plus 55 over 10. And now that we have them all with a common denominator, we can actually evaluate this. So 22 plus 33 is going to be 55 over 10, plus 44 plus 55 is going to be 99 over 10. And now 55 plus 99 is the same as doing 100 plus 54, right? So it's going to be 154 over 10. And when you convert that back, how many times does 10 go into 154? 15 times. And you have a remainder of 4 over 10, right? So that's going to be our answer, but we can simplify that to be 15 and 2 over 5. And that is going to be answer choice D. So I hope this video was helpful. If you guys have any questions, feel free to ask in the comments. And yeah, just make sure you keep watching, because we are going to keep releasing a lot of English and math videos. So thank you so much for watching.